questions 11 through 20 on the 2010 grade 11 Fermat math contest. A loonie is a dollar coin and a dime is a 10-cent coin. One loonie has the same mass as 4 dimes. A bag of dimes has the same mass as a bag of loonies. The coins in the bag of loonies are worth $400 in total. How much are the coins in the bag of dimes worth? L over D, loonies over dimes, is in the ratio 1 to 4, according to the mass. Now they've given us 2 bags, and one bag has a whole bunch of dimes, and the other bag has a whole bunch of loonies. Now they tell us that the loonies are worth $400. Now each loonie is worth $1. So that means that there are 400 loonies in that bag. Okay, straightforward. Now we use this equation to figure out how many dimes there are. Since these bags have equal mass, L over D is retained, and that is of the ratio 1 over 4. But L, we are told, or we figured out, is 400. So instead of L, I can put 400, and this allows me to calculate D. D, therefore, would be 1,600. So there's 1,600 dimes in the bag. Now we have to calculate the value, how much those dimes are actually worth. Well, each dime is worth 10 cents, so $0.1. So 1,600 times 0.1, and that is going to be $160. So number 11, the answer is C. When K candies were distributed among 7 people so that each person received the same number of candies and each person received as many candies as possible, there were 3 candies left over. If instead 3 K candies were distributed among 7 people in this way, then the number of candies left over would have been. So as always, I would like to use a number, just makes it much less abstract. Any number you want to choose is fine. I'll just choose 10. And the reason I chose 10 is because 10 divided by 7 gives a remainder of 3. So any number of that form would be appropriate for this question. So I've got 7 people, and based on the question, they're going to get the maximum number of candies so that everybody gets the same number of candies. And the only way to do it when K is equal to 10 is 1. So everybody gets 1. This is the maximum that each of them can get, and each of them has the same number of candies. So I've given out 7 candies, but I had 10. How many do I have remainder? 3. So far I am abiding by the rules of the question. Now we're doing the same scenario, but for 3K. Well, 3K is 30. And again, I've got to distribute them among 7 people in a way so that everybody gets the same number and everybody gets the maximum. Well, 30 divided by 7 is 4. In terms of the maximum it could be in as an integer value. So everybody gets 4. And therefore, how many candies have I given out? 4 times 7, which is 28. Of the 30 candies, I've given out 28, so my remainder is 2. So number 12, the answer is B. 50 numbers have an average of 76. 40 of these numbers have an average of 80. The average of the other 10 numbers is. So x1 plus x2 all the way up until x50. If you take that average, which of course you have to divide by 50, they're saying is 76. Okay, so that's the first part of the question. Now they also tell you that 40 of those numbers have an average of 80. So let's just say the first 40. It doesn't really matter. So x1 plus x2 all the way up until x40, if you take the average there, you're dividing by 40, that average is 80. So now they're saying those other 10 numbers, what are the average? So x41 to x50. Okay, well, from this equation right here, x1 plus x2 all the way up until x40, that sum is 40 times 80, if you just cross multiply like this. And that is, of course, equal to 3,200. So going back to this original equation, we can plug that in. So x1 plus x2 all the way up until x40, that is 3,200. And then, of course, we have x41 all the way up until x50. Now, we know that whole sum, if you were just to cross multiply right there, is 50 times 76. And then this part, those guys, are valued at 3,200. So now, I've got pretty much everything I need to figure out the question. This is going to be 3,200 plus x41 to x50, and that is equal to 50 times 76. So 50 times 76 is 3,800. If you subtract the 3,200, you get 600 on that side, and you're left with this. Now, they want the average of this, not the sum. The sum is 600, but they want the average. To get the average, you just divide by the number of terms, and there's 10, right? So divide both sides by 10. And that would represent the average, and 600 divided by 10 is, of course, 60. So number 13, the answer is A. 4 friends went fishing one day and caught a total of 11 fish. Each person caught at least 1 fish. All of the following statements could be true. Which of the following statements must be true? We've got to fiddle around with this and see what we can get. So I just want to do extreme case scenarios, and hopefully that will let me eliminate some of these. So we've got 11 fish, right? So the minimum that each person gets is 1. Each person caught at least 1 fish. So let's just say 1, 1, 1, but then all the other fish was caught by the 4th person. So that means he caught 8. So this is one extreme case scenario. It's very uneven. The other scenario on the other end of the spectrum is when it's completely even. But 11 is not divisible by 4, right? So it can't be completely even, but we can get pretty close. We can do 3, 3, 3, and 2. That's about as even as we can make it. So based on these two extreme case scenarios, let's go through the answer choices and see what we can eliminate. A. At least one person caught exactly 1 fish. Well, that's not true here. At least one person caught exactly 1 fish. No, none of them caught exactly 1 fish. Okay, so that's wrong. Okay, B. At least one person caught exactly 3 fish. Well, that's wrong too if you look at the first scenario. Because in the first scenario, which is right here, nobody got exactly 3 fish. So that's wrong. If something is true, it's true for any scenario. C. At least one person caught more than 3 fish. Well, in this scenario, nobody caught more than 3 fish. So that's wrong. D. At least one person caught fewer than 3 fish. That's true here and that's true here. Here, these guys caught fewer than 3 fish. And in this scenario, this guy caught fewer than 3 fish. So that one is true so far, so let's keep that. E. At least 2 people caught more than 1 fish. At least 2 people caught more than 1 fish, and that is not true in this scenario because only one person here caught more than 1 fish. So I guess by process of elimination, the only one that checks out is D for number 14. The number of positive integers p for which -1 is less than root p minus root 100 less than 1 is -1 is less than root p minus root 100 is less than 1. So we can obviously immediately get rid of that root 100, just call it 10, like this. And there's several ways of doing this. You can put the 10 on either side, so add 10 to everything. And if you do, you just get root p is between, looks like 11 and 9. Yeah. So that means the square root of some number is greater than 9 or it's less than 11. Well, be very careful here because it's less than. It's not less than or equal to. Okay, because you notice the answer choices are very close together because they're anticipating that you're going to also include something that you shouldn't include. So first and foremost, if you take the square root of something, it's got to be between 9 and 11. So I think that P definitely could be 100 because the square root of that is 10, and 10 would be right in the middle of these two numbers. So at first you think, okay, well, is there anything else? And the answer is, of course, there's several more. But let's, again, do extreme case scenarios. What number could P be for it to be exactly 9? Well, P would have to be 81. And that means that root P would be 9. Here, root P is 10. And then my question is, what would P have to be for the root to be 11? Well, it would be 121. And that would be 11. So these are our boundaries. We can't choose P equals 81 because that would make it exactly equal to 9. It can't be equal to 9, it has to be greater than. But any number greater than P, that is an integer, so 82 and so on, all the way up till the other end, which would be 120. All those numbers are legitimate because when you take the square root, they will be either greater than 9 or less than 11. So all of these integers would work out. And if you count those, it's basically 120 minus 81, and that's 39. So number 15, the answer is D. Positive integers a and b satisfy a times b is 2010. If a is greater than b, the smallest possible value of a minus b is. A times b is equal to 2010. Now, the best thing to do is to break up 2010 into its prime factors, and that will allow us to sort of select what a and b could be. And the prime factors are 2, 3, 5, and 67. So we have to figure out what a minus b could be, and in particular, the smallest possible value. Well, the smallest possible value is probably going to be obtained when the numbers are as close together as possible. Like, for example, if I chose, any of these numbers, like, for example, if I chose b is equal to 2, well, a would have to be the product of those other three guys, and that's going to be very big. 3 times 5 times 67 is 1005. So we satisfy that a is greater than b, but then when you do the a minus b, it becomes 1003. So that's pretty big, and it's not even one of the answer choices. So we have to choose something that will give us a very small value. And what I immediately notice is that if you choose 67 for a, then b is going to be 2 times 3 times 5, which is 30. And therefore a minus b is 67 minus 30, which is 37. And that is one of the answer choices. And it's the second smallest. The smallest is 1. And there's no way to get 1. It's impossible using the prime factors of 2010. So the answer to number 16 is A. In the diagram, PQRS is a rectangle with PQ equal to 5 and QR equal to 3. PR is divided into 3 segments of equal length by points T and U. The area of the quadrilateral STQU is. STQU, this is the quadrilateral they want us to figure out. So we have to figure out STQU, and that is going to be done as follows. First, you take the area of the entire big rectangle, and they've given us that it's 5 and 3 as the dimensions, so the area is 5 times 3. From that, of course, we have to subtract this triangle, that triangle, this triangle, and of course that triangle. If you subtract those 4 triangles, you'll get left with just STQU. So the first triangle, of course, is this one right here, and I'm just going to draw a height. So we're subtracting 1/2 base times height, like that. But the thing is, this triangle is exactly the same as this triangle right here. So instead of just 1/2 base times height, 2 times 1/2 base times height. Since those two triangles we can just combine. The base is just 5 right there. But what about the height? This distance from there to there, what is that? Well, this sentence is what's going to help us determine that. PR is divided into 3 equal segments of equal length. So that means that this and this and this are the same. They're a third. So if you were to draw lines from there to there, like that, they would chop the other half, or the other part I should say, into thirds. So if you draw a line from there to there, it cuts PS I should say, into thirds. So that basically means that this becomes 1, this is 1, and this is 1. So that means this height is 1. So I put a 1 there. And then very similarly, now we got to figure out from here this area, and that triangle is exactly the same as that. So we've got to subtract 2 of those. So minus 2 times 1/2 base times height. The base is from there to there, which is this 3. Now we got to figure out the height, which is from there to there. So in a very similar way, you draw lines to the other end like that. And since this is a line that's been chopped into 3 equal parts, when you draw lines to SR, it chops SR into 3 equal parts. So that means this is 5/3, this is 5/3, and this is 5/3. So that means this height is 5/3. And that will give you the area. So here we go. This is 15, this is 5, and this is 5. So 15 minus 10 is 5. So number 17, the answer is B. A rectangle is divided into 4 smaller rectangles labeled W, X, Y, and Z as shown. The perimeters of the rectangles W, X, Y are 2, 3, and 5 respectively. What is the perimeter of rectangle Z? Let's just label this. So I'll call this side A, and therefore this is A and this is A, right? Because the lengths will just be the same. I'll call this side C, and therefore this is C, this is C. This side I'll call B, and therefore this is B, this is B, this is B, and finally I'll call this side D, D, and D. So now let's talk about the perimeters. For W, the perimeter they're saying is 2, and in terms of my lettering, it's 2A plus 2C. For X, they're saying that perimeter is 3, and my lettering, it's 2B plus 2C. And for Y, that perimeter is 5, and my lettering is 2A plus 2D. And the question wants me to find the perimeter of Z, which is 2B plus 2D. This is what I have to find the numerical value of. Okay, I think I've got more than enough to do that. The first thing I'm going to do is just add these two guys. I think that should help us, hopefully. So if I do, I get 8 on this side, and on this side I get 2A plus 2D plus 2B plus 2C. And this looks very similar to what I want. I want 2B plus 2D, and that's this guy and this guy. So that's very helpful that it turns out like that. But then the other two terms are 2A plus 2C, these two. But 2A plus 2C, right up here, is equal to 2. So that means 8 is equal to 2B plus 2D. And then this guy right here, that is equal to 2. So putting everything on one side, it means 6 is equal to 2B plus 2D. And that's it. Number 18, therefore the answer is A. In the diagram, PQ is equal to QR, RS, SP, and SQ, and they're all equal to 6. And PT and RT is 14. The length of ST is. Let's start by labeling as much as we can, but before we start labeling, I'm going to draw a line that connects P to R. And that's going to help me. And then I'm going to connect S all the way to T, since that is what they want us to figure out. And then I think I'll just label this intersection point M right here, this point right here in the middle. Okay, I think that should be sufficient. So first and foremost, I can notice that this is going to be a right angle. So I've got a Pythagorean relationship that MT squared plus PM squared is equal to PT squared. Now PT, they told me, is 14. PM, I don't know yet, but I can pretty much figure that out. And then MT, that will be, of course, what will help me figure out ST. Because in the end, once I get the value of MT, they want me to figure out ST, right? So ST will just be MT minus MS. That's it. So we just have to figure out a few of these variables. And we're going to concentrate on this triangle right there, this one, the one connecting P, S, and M. Now you'll notice that this is all equilateral triangles, right? They tell you that in the question. So when I chopped it in half like that, I've created a scenario that is very common in math contests. I've created a 30, 60, 90 triangle, right? 30, right angle, and 60. So the ratios of the sides are 1, 2, and root 3. So, do we know any of these sides? And the answer is yes. We know that PS is 6. So we have an actual numerical value for PS or SP, whichever way you want to call it. And then MS, well, MS is just half of QS. And QS, or SQ, is also 6. So MS is just going to be 3 in terms of its actual value. So I think that's all we need. And then PM, in a very similar way, you can figure out PM over MS, which is 3, is equivalent to root 3 over 1, right? So cross multiplying, you get PM is equal to 3 root 3. So now we have everything we need to solve. PM I put in here, 3 root 3, and then MT, I'll just leave it empty for now. So that means MT squared is equal to 14 squared, which is 196. 3 root 3 squared would be 9 times 3, which is 27, so subtract it on that side. And you get 169 is equal to MT squared. Therefore, MT is the square root of that, which is 13. And then now to finally figure out ST, that's MT, which is 13, minus MS, which is the distance from there to there, which is 3. So ST, therefore, is equal to 10. So number 19, the answer is D. A square has side length 5. How many different locations can point X be placed so that the distances from X to the 4 sides of the square are 1, 2, 3, 4, 5? Let's talk about one such square, and then we will see how many different ways we can do this. From the answer choices, one thing is for sure, that the answer has got to be a multiple of 4, because all of them are multiples of 4. So let's give a first scenario. Let's say we have a line that is approximately here, and I'm going to draw a line from here to here, and then I'll explain what I'm doing. So the square has a side length of 5, right? So if I chop it up into 1, 4, 2, 3, like this would work. This point would be my X right there, And that x is 1 from this side, it's 4 from this side, it's 2 from this side, and 3 from this side. So that works. I've got 1 so far. But this can be alternated in a few ways, right? The other way is, of course, to flip the numbers. Instead of 2 and 3, we can do 3 and 2. So that means the line would have to go a little bit lower. And, this is not exactly drawn to scale, but you guys get the idea. So, for example, this is now 3, and this is 2, and this is 1 and 4. So as you can see, my x is now here. It's in a different spot. Well, I can also do the same kind of story by flipping the 4 and the 1. So instead of having it like this, I could have it like this and like this, approximately. And the lines would be 4 and 1, so here or here. And as I previously mentioned, don't worry that this is not drawn to scale. I just wanted to show you the numbers. 4, 1, this is 2, 3, 4, 1, and this is 3, 2. So I've got x and x. Correct? So I'm tempted to choose 4, but I have a hunch that it's more than 4 since that's the second lowest. Okay, not a problem. How do I get another set? Well, in these first 4, I had put the 1, 4 in the horizontal position, right? Now, I'll put the 2, 3 in the horizontal position. So these guys will be divided 2, 3. And that should be able to do it. So this is going to be 2, 3. So this will be 1, 4, like this. So for example, this is 2, this is 3, this is 1, and this is 4, like that. And therefore this is x right here. And in a very similar way, I can flip the 2 and the 3 so that we have the 3 here and the 2 there, and the 1 and the 4 like that. So again, I've got a different x. And I can do the exact same thing this time, but I'm flipping now the 4 and the 1. So instead of the 1 going on top and the 4 going on bottom, we put the 4 on top and the 1 on the bottom. So these types of scenarios. This is now going to be 2 and 3, and this will be 3 and 2. So label these to illustrate what I mean. This is 4, this is 1, and this is 2, this is 3. This is 4, this is 1, this is 3, this is 2. So again, I've got x and x. And if you look at these all, you'll see all of them are different with regard to where x is. So therefore, I created 8 different scenarios, and therefore number 20, the answer is D.